This week on Arizona Illustrated, new glasses allow colorblind people to see in full color, but do they work?
These glasses, I think, are gonna open my eyes to what I've been missing these many years.
Follow an artist's journey from skateboarding to painting.
I knew there was something in me building up within me, and then when I graduated, it was like I didn't have to answer to anyone anymore and just kind of let the painting come out.
Visit an important scientific laboratory located in the Catalina Mountains.
Here in the Catalina Mountains in our Criticals and Observatory, we're able to look and see how these soils differ from one another and how we can relate those to environmental variables.
And the latest installment of our ongoing Desert Plant series.
The more space you give it to be its fully natural self, the prettier the plant will be.
Hello, and welcome to an all-new episode of Arizona Illustrated. I'm Tom McNamara, and we join you from Tucson Botanical Gardens. Beautiful place. You know, it's full of lushness and vivid colors, and that's what causes a lot of people to venture here. But can you imagine not being able to see the whole spectrum of color this place has to offer? Well, in our next story, you'll meet Arizona Illustrated producer John DeSoto, who we just learned is colorblind. And now we'll witness John and other colorblind individuals trying on special corrective lenses that allow them to see shades and hues of color they've never seen before.
Most of the time I just tease him about the color choices of his apparel.
Fashion sense.
Right, so what colors are you wearing now, John?
So I'm wearing my favorite brown shirt.
So the idea for this story came about when my colleague, John DeSoto, here's John, came to work wearing a salmon-y pinkish shirt, this shirt. And I commented that it was an interesting color in him, and he said, "Oh really? I wouldn't know. I'm colorblind." Surprised by this, I asked him if he ever tried those corrective glasses ever. And he said, "No, they're just kind of expensive." So naturally, I decided to do a story about this and set out on a mission to get John these glasses. And just when I was researching how to go about this, we learned of a partnership between Arizona State Museum and EnChroma, the company whose co-founder, Don McPherson, was the one who actually invented the lenses designed to address the symptoms of colorblindness. So it was all just kind of meant to be. This partnership is part of EnChroma's Color Accessibility Program, where they donate glasses to organizations like schools, libraries, and parks so that people with colorblindness can experience those spaces in more vivid color.
In my life, I've not run across that many people that really seem to be interested at all.
When it came to colors, I'd just back off and not say anything.
And I'm a student here, and I'm studying archaeology. And that's a lot of where I hope that these glasses will help things be easier for me.
Oh, these glasses, I think, are gonna open my eyes to what I've been missing these many years.
On this day, 4 colorblind individuals were invited to the museum where a press conference was held to witness their first experiences with the glasses.
The biggest thing is it's embarrassing because I can't match clothes up well. My wife really gets on me about that.
Like John, one thing they all have in common is having trouble getting dressed.
My wife always had to dress me because of a wrong color tie, wrong color shirt, wrong color pants.
Apparently, I'm a moderate dresser. I've never had, with the exceptions from purple socks that my kids made me buy.
Or it hasn't ever prevented me from actually doing something. Just in my profession, the only thing that it's hindered is when it comes to color grading footage. I'm probably not the best person for that job.
And it hasn't ever really hindered their lives or professions in any significant way.
I was an audio recording engineer, so being colorblind was not a big deal.
I was a pharmacist, because then you just went by identification, the markings on them and the size and all that.
I was a university professor for about half of my career and a working engineer. I've never struggled over it.
And their colorblindness seems more interesting to those with normal color vision, perhaps because they don't know what they've actually been missing, and we can't imagine a world without the full spectrum.
For these many decades, it's not a big deal to me any longer.
So I don't actually know maybe how bad it is for me.
But it's going to be interesting to find out.
So what is colorblindness? First of all, the biggest misconception is that colorblind people see the world in only shades of grey, black and white. This is called achromatopsia, and it's extremely rare, affecting only 1 in approximately 30,000 people. Whereas the most common types, which is red-green colorblindness, affects approximately 300 million people worldwide. And maybe you're wondering why all the colorblind people in this story are male. That's because it's a sex-linked genetic mutation that is passed on the X chromosome. Females have 2 X chromosomes, so if a female inherits 1 normal X chromosome and 1 with the mutation, she won't display the mutation since it's a recessive gene. Males are more likely to be colorblind since they don't have a second X chromosome to override the chromosome that carries the mutation. And this is why 95% of colorblind people are male. Physiologically, colorblindness happens when a type of nerve in the retina, called a cone, isn't working correctly. These cones are what processes light as it enters our eyes and sends signals to the brain that allow us to perceive color. And there are 3 types of cone cells, and each has a different sensitivity to blues, greens, and reds. Typical color vision involves the slight overlapping of these 3 cones, and this enables us to detect up to 1 million different shades of color. Color blindness happens when these cones overlap more than normal, and this causes confusion between specific colors. The more overlapping of these cones, the more color confusion it creates. And there are different types and intensities of color blindness. One way to find out what type of color blindness you have is to take an online test, as John is seen doing here. And this allows EnChroma to determine what type of color blindness you have and what lenses will be most effective.
No, nothing. Nope. 3. Nothing.
So how do the glasses work? By using advanced spectral notch filters, EnChroma glasses selectively filters out wavelengths of light at the point where confusion or excessive overlap of color sensitivity occurs. Upwards of 80% of people affected by these types see an improvement, allowing them to perceive more colors in bright and vivid detail.
Oh dear, well, that's way different. These 2, without the glasses, and these 2, they're pretty much equal in brightness, intensity, and in color and saturation kind of thing, but now they're way different.
Well, what I can see better is each individual piece I can pick apart.
Our wall of baskets.
Wow. Those are something. Wow, look at that.
EnChroma makes glasses for both indoor and outdoor settings, and when the 4 participants went outside, they experienced a much more dramatic difference.
Wait, are these trials red?
Yes.
Oh. Oh yeah. Oh, man. Yeah, that's red, all right.
It's red brick, but it's...
Here, you want next?
Yeah, let me...
Yeah.
And for John's big moment, I brought him to the most colourful place I could think of, the Tucson Botanical Gardens, where we were joined by his wife and daughter.
I expect to see more vividness in sort of greens and reds, since those are the 2 main colors that affect the type of color blindness.
Once we did do the color tests, it was phenomenal to kind of notice. We all see 7. You don't see the number 7?
I guess I don't know what to expect. This is exciting.
Palms are sweaty.
Ooh.
Seriously?
Oh my gosh. That's weird. That's purple.
That's what that
It's.
Can you see
Those are definitely red.
What are those?
That's definitely red. Oh, like the contrast in the red and green is super significant.
Look at your shirt.
It's green. Oh,
For sure?
dang.
Where is it?
That's green.
What did you think it was before?
It's brown. That is weird.
Look how green the vines.
Those are very green.
I'm left wondering why it's so moving to witness someone with colorblindness using these glasses. I think because it's so sad to think of the world any less vibrant. But this is subjective. There are in fact many, many more colors that people with normal color vision can't see, like infrared and ultraviolet. And it's impossible to even imagine what they look like because we lack the visual literacy to articulate them. But perhaps one day the technology will exist that will allow us to see how much richer and vaster the world and cosmos actually is.
That's red.
Now, if you or anyone you know is colorblind, you can now visit the Arizona State Museum to try these glasses. For Gavin Hugh Troy, the roots of creative life began with skateboarding, creating something from nothing by building ramps, emptying swimming pools, or skating ditches or streets. Now he's one of downtown Tucson's longest-running artists, and he pours his life's journey onto his canvases with a lyrical brilliance.
I try to spend at least one day a week still skateboarding. I go out and skateboard at the park with my friends. When I'm skateboarding through an empty swimming pool or down a sidewalk and I'm drawing lines on my skateboard, the abstract pieces can kind of be like that sometimes when I'm working on them. So it's cool. It's neat to see like how things come up to the surface from your past and influence you in ways. I was taking pictures of skateboarding and documenting skateboarding along with learning about fine artists like Ansel Adams and Cartier-Bresson photographers. So I feel like my creativity began a lot with that. My parents are both creative. My mom, I always remember her like developing pictures and using the darkroom and taking pictures of my sister and I. And my father was a potter, so I kind of grew up in that environment. I graduated with a degree in intermedia, but then when I left school, I really wanted to paint. I knew there was something in me building up within me, and then when I graduated, it was like I didn't have to answer to anyone anymore and just kind of let the painting come out. It's a gift to be alive. Practice yoga in the morning and meditation, and then doing my computer work and sketching, and then come in here to the studio. I sometimes may have some goals in mind, or I may just come in and just be free. Pick up a piece of wood, look at some sketches, and just start working into pieces. Sometimes I'll ask, well, how did you find my work? And then I'll get some interesting story about, because if it's up in different places or whatever. So yeah, nice to meet you guys.
Your work.
Thanks so much.
Yeah, it's so great in our space.
When I first started painting, like after college, I was really also searching within myself spiritually, and I feel like the paintings kind of allowed that to happen as well. Like they were along for the journey, or it was like a record of this journey of an exploration or learning about myself. It's like as I unfold, the paintings are unfolding, and it's just like a never-ending journey. If I'm uninspired, which is usually not happening, but if I am, I'll like sand wood or cut some wood or make a frame or stretch canvas. So there's always something to do. It's kind of like opening up that faucet, you know, and just letting things pour through. So always exploring, looking at other art and drawing, looking at nature and drawing, or drawing from my imagination, writing out ideas, and transfer that onto whether it's canvas or wood or sculpturally found objects. The ones that I've been working on are more like the narrative pieces, so they're figurative, and it's almost like the figures in my paintings, but three-dimensional, of course, and they're like the narrative pieces, and for me it's just exploring the form and freedom of the spirit. I love being not locked into one form necessarily. Have you ever been hiking where you just are going around the next, you just want to see like what's around that next bend? And that's really what keeps me so motivated, the unknown and what's going to happen next or what's going to come up next in the paintings. So that really, like, from the time I wake up, I'm just excited to explore that creative spark inside.
In 2009, the National Science Foundation funded the development of almost a dozen critical zone observatories, intended to be environmental laboratories, all focused on the Earth's outer skin, where water and soil and rock and atmosphere and ecosystems interact. And one of those observatories was set up right here in southern Arizona.
I have felt most relaxed, most at peace, and most also stimulated and I guess happiest when I've been out in the natural world. And I regain that feeling when I get out into the critical zone observatory sites. Here in Tucson, we live at the foot of the Catalina Mountains. And as you drive up, you go through a variety of ecosystems. You go from the Sonoran Desert ecosystem down at the foot of the mountains, through savanna woodland. You keep going a bit higher and you start to see ponderosa pine trees. And you go even further and you get into what's called mixed conifer forest. The Critical Zone Observatory was designed to take advantage of this gradient.
Critical zone science requires understanding the physical, the chemical, and the biological factors that influence life on Earth. So you need to know all of it. It encompasses everything from where groundwater interfaces with the bedrock, all the way up to where you have atmospheric exchange occurring at the tops of tree canopies.
We actually live on and take advantage of a very thin layer of the Earth's surface. And it's termed critical because arguably all of life on the planet depends on the presence and functioning of that portion of the Earth's land surface.
The critical zone, in a variety of ways, spans across an enormous multitude of scales, temporally and spatially. We can think about an entire hill slope or even an entire basin, all the way down to a tiny nanoparticle. And part of my work is aiming at looking at the smallest constituents of the critical zone and contextualizing them within larger scale processes.
So when the Critical Zone Observatory program was first developed, the National Science Foundation conceived it as a network of sites where all of the sites would have specific science questions they were trying to answer. And we were selected here in Arizona in part to represent the hotter and drier end of the climate regime. What we want to do is to understand what are the feedbacks between the microbiology and the hydrology and geochemistry, and how do they couple with each other and interact. And you can only do that by bringing the data sets together as a team and looking at the cross relationships between them.
The different bacterial and fungal communities that exist up at the surface are actually going to be fundamentally different, both in terms of who they are and the type of work that they do as we go deeper down into the soils. So we often think about, how are soils formed? It's through the physical and the chemical, but also the biological weathering of rock. And so one of the current research questions that we're really excited about and really interested in trying to answer is, how does the interplay between what's happening at the surface and then what's happening in the subsurface, how does the interplay between those processes create the evolution of soils and influence the distribution of the microbes that are living in and along this entire soil profile?
Using this vacuum pump, I'm able to extract water from the soil into this collection bottle, which we can then bring back to the lab and analyze.
Soil is fascinating because it's where the non-living meets the living. The geologic underpinnings of the critical zone took hundreds of millions of years to develop and are forming into what we currently observe today. And at the same time, a lot of the chemical reactions that take place in soils can happen, in under 15 minutes.
We also have folks like Craig Rasmussen, who have been looking at how this process of water movement through this catchment is transforming rock into soil.
We're trying to understand the long-term evolution of this whole landscape. So behind me, there's a great example of one of the natural processes here that moves and redistributes mass and material across the landscape. We have trees, as they fall, you can see it brings up a big root ball with it, which brings a lot of soil. That soil can then move by gravity down slope. What I enjoy is going back to the same landscape repeatedly. You see the landscape as a whole and how it all fits together, and you're like, oh, I can see how this whole process works. Soils are kind of it's the story, and it's not always easy to understand the story, so you have to decipher it and translate that from what you measure to what's going on in the environment.
Studies of the critical zone are essential for being able to not just predict the future of the Earth's surface and the world that we live in as humans on the planet into the future, but also to be able to develop solutions to many of the problems that we've created for ourselves.
We are experiencing rapid climate change. We are experiencing more frequent droughts and hotter temperatures here in the Southwest. And if we don't have a holistic understanding of a system, then we are not going to be able to make meaningful and informed decisions about how we might manage that system. We have to remind ourselves that as humans, we are part of the ecology of this biosphere. We are part of the organisms that are interacting with the other organisms in this system. And so we have an inherent role there as well.
My hope is that through learning about how humans have an impact on critical zone processes, we can move our interventions and our approaches to critical zone management to a place that will sustain the health of the ecosystems, that will allow us to be nourished by those ecosystems and be sustained by those ecosystems long into the future.
In this next story, Tucson Botanical Gardens Director of Horticulture introduces you to this plant. It's a tough shrub with a name that's a lot smaller than this is. It's called the little leaf cordia, the latest in our desert plant series.
This is one of my favorite desert shrubs because it flowers all summer long. It is evergreen, and it takes very little water and truly loves full sun. It can take the hottest of conditions that you give it, and it can take some of the driest conditions of any leafy plant here in the Sonoran Desert. If you want it to flower more consistently and more often, a little additional water goes a long way. It can be anywhere from 6 to 10 feet tall and 6 to 10 feet wide. The more space you give it to be its fully natural self, the prettier the plant will be. This plant does not take very well to manicured pruning, so the more you prune it, the weirder it will turn out to look. It is host to galling insects, and galling insects refers to insects that spend part of their life cycle inside of the plant, and the plant grows around them. This causes sort of a strange tumor-looking growth on either the leaf or the stem, depending on where the insect has gone in. This does not generally affect the plant's overall health. It can cause what some people would consider cosmetic damage, but it also just provides a natural look to the plant and looks pretty interesting to a grower. It is a native insect, and the plant has evolved with it. The Tucson Botanical Gardens is an organic garden with an ecological focus on our plant maintenance, and so we don't worry about insects that aren't killing plants. The little leaf cordia is a great landscaping plant because it does not have thorns, and so it provides this very soft look on the landscape. Lots of habitat. It's a place where you'll find birds and rabbits either in the shade or making nests. Because it flowers regularly throughout the summer, it's an important pollinator feeder, and because they're not a high water use plant, they'll also be in those spaces between wet areas, and they almost provide their own oasis.
Thank you for joining us here on Arizona Illustrated. I'm Tom McNamara. We'll see you again soon.